So next is formation of boron trifluoride by valency bond theory. Okay. So valency bond theory tried to explain the formation of boron trifluoride. So boron trifluoride forms covalent bond. So if we draw the Lewis structure of boron trifluoride, it should be like this. Fluorine makes single bond. So 7 plus 1 octet complete. This fluorine also octet complete, 7 plus 1. This fluorine also octet complete. For central atom boron, okay, the central atom boron has how many electrons? Its valency shell has 3 electrons. Now 3 electrons added, you get 6 electrons. Okay. So central atom boron is getting 6 electrons in the valency shell. So it is getting 6 electrons in the valency shell, means octet not complete, incomplete octet. Incomplete octet. The question arises how boron trifluoride is formed. So boron trifluoride is formed. It is explained by valency bond theory. So in valency bond theory, it is told that octet complete is not the necessary and sufficient condition. Octet complete is required, but it's not essential. The bond is formed due to overlapping of atomic orbitals, where the orbitals unpaired electrons will get paired. Okay. So now you see boron. Suppose
Sir, can you repeat this part again?
in boron trifluoride, boron is getting incomplete octet. Boron is valency shell 3 electrons, and due to 3 covalent bond, its 3 electrons increase to 6. 3 plus 3, 6. So incomplete octet, how it is formed? Lewis theory cannot explain. Now valency bond theory explains.
Your voice is cracking. It's difficult to understand.
Sir, your voice is cracking.
It's very difficult to understand anything.
Okay. A network problem. Now is it okay? Is it audible or still cracking?
Sir, still cracking.
Still cracking.
Okay, I changed the network. Let us see. Now see, check whether network is okay or not. Check. Suppose we are taking boron. Electronic configuration is 5. 5 is the atomic number. Electronic configuration you can write 1s2, 2s2, 2p1. So in ground state, boron is having only one unpaired electron. 2s2 is paired. So this is in ground state. Since boron is making 3 covalent bond, so there must be 3 unpaired electrons required. 3 unpaired electrons required. By boron atom to form 3 covalent bonds with fluorine. 3 covalent bond with fluorine atom. 3 covalent bonds 3 covalent bonds with fluorine atom. So 3 unpaired electrons must be required, but there are only 1 unpaired electron. So in ground state, boron is not eligible to form bond. Then in excited state, it will absorb energy. In excited state, it will absorb energy. If it absorbs energy, then some electrons in lower state will be going to higher state. You see, in boron, 2py, 2pz are vacant. So 2px having 1 electron, 2py, 2pz are vacant. Then boron in excited state, this is your ground state. In excited state, what will happen? Electron from 2s will jump to 2p. So 2x electron will jump to 2p. It will jump to 2p. So 2px is there and it will jump to 2py. So thus we get 3 unpaired electrons. 3 unpaired electron आ गया. Okay. So if we get 3 unpaired electron, now it is eligible to form bond. So boron can form bond. Okay. So if it is having 3.
Sir, can you please repeat?
So boron, 1 electron from 2s2 jump to 2py like this. So you will get 2s1, 2px1, 2py1. So 3 unpaired electrons are there. So due to 3 unpaired electrons, boron can form 3 bonds with fluorine. So 3 unpaired electrons requirement is fulfilled. Okay. 3 unpaired electrons requirement is fulfilled. So we get now it can form covalent bond with fluorine. In fluorine atom, we can get like this. Suppose fluorine, your fluorine is 9. So what can you write? 1 is 2, 2 is 2, 2px2, 2py2 and 2pz1. Okay. So this you can also write like this, or 1 is 2, 2 is 2, 2px2, 2py1, 2pz1. Okay. Or you can write like this, 1 is 2, 2 is 2, 2px1, 2p, 2py2, 2pz2. Okay. So the unpaired electron can be written here or here or here like this. So fluorine will overlap. Now you have boron.
Sir,
Yes,
in the second one, it will be 2PZ2, right?
Yes, sir.
yes, 2pz, 2pz. So now fluorine can overlap from here. So if you have this is 2px, say if you have this is 2px, 2py, and this is 2s. So 2px unpaired electron. So this one 2px unpaired electron. This part can overlap. Okay. So boron we can write again. This is boron. How bond is formed? We can have two diagrams. One is box diagram, another is orbital diagram. So we are doing box diagram. How bond is formed like this. Say 2px, 2py of boron. This is 2s. Now fluorine, you have fluorine. So one fluorine you can take fluorine 2px of fluorine. Another fluorine we can take 2py of fluorine. Okay. One more fluorine we can take anything, say 2pz, 2pz of fluorine. Okay. So now 2px will overlap with 2px, sigma 1. 2py will overlap with 2py, then it will form sigma bond. And 2s will overlap with 2pz, it will form also sigma bond. So 3 sigma bonds are formed. So we'll get 3 sigma bonds in this way. Now let us write S and p orbital of boron here. So S orbital of boron can be written like this. So this is boron, S orbital, and 2px and 2py. This is 2px. This is 2py. So this is 2px. Two px. This is 2py. This is boron. Boron. Now 2px of boron overlap with 2px of fluorine. So fluorine will come from here. Now 2py of boron overlap with 2py of fluorine. This is fluorine 2py. Now you have 2pz. So 2pz and 2s will overlap. 2pz will overlap from this is spherical, na? 2s is spherical. So 2pz will overlap from z axis. 2pz of. So this way boron trifluoride bond is formed. So unpaired electron becomes paired due to overlapping.
Sir?
And there is no requirement of octet complete. Unpaired electron gets paired and sigma bonds are formed. So like this 3 sigma bonds are formed, explained by Valency bond theory. But in this theory one problem is there. Here the overlapping is what? 2p x, 2px, 2py, 2py, and 2s, 2pz. So this is fluorine, this is boron. This is the overlapping, type of overlapping. Overlapping, type of overlapping. So if you get this type of overlapping, okay, here it says that all 3 bonds will not be equal strength because we have studied in last class your PP overlapping is greater than Sp overlapping is greater than Ss. So all 3 bonds may not have equal bond strengths.
Sir, SP overlapping from sigma bond.
Yes, may not have equal bond strength. So 2 bonds will be equal, but one will not be equal with other 2. This is the observation from the theory. But what is the experiment? Experiment suggests that boron trifluoride is like this. The experiment suggests that all 3 bonds have equal bond strength. This is the experiment. All 3 bonds have equal bond strength. Equal bond strength. And also equal bond length. Bond length also equal. Bond length and bond strength both are equal. If bond length, bond strength both are equal, then this theory may not be Correct. Is it okay? Have you written?
Yes, sir.
Note down or take screenshot.
Sir,
Yes, tell me.
sir, in boron, the spherical shell which is shown, it is 2s, right?
Yes.
Okay, sir.
If completed, tell me. Okay.
Completed.
Done, sir.
Okay. So I'm going to next page. All have done? So there is a modification of this theory, and it is told that in order to make all the bond length equal and bond strength equal, they have modified this theory, and they told that there is a mixing of S and P subshell before they overlap. It is told that there is a intermixing of S and Px and Py subshell. Intermixing of these subshell or orbital, whatever you say, these are orbitals actually. Intermixing of orbital. So there is an intermixing of orbitals that takes place. Intermixing of orbitals that takes place before overlapping. After that, that will overlap. So suppose you have boron. So boron, if you have, say,
Sir,
S, 1s2, 2s1, 2px1, 2py1, 2pz0. Okay. So this you can write like this. Like this, like this, like this. So before overlapping, they will mix.
क्या है?
Before overlapping, they will mix. Means S subshell is spherical. This is S plus P subshell Px you take. Px is taking like this.
sir,
Yes. Tell me.
sir, after overlapping the shape of the orbitals will change.
Change. It will change. So, so S subshell mixed with Px and Py. So after mixing, you will get orbital, and that orbital is known as hybrid orbital. Hybrid orbital. Why? Because this process is known as hybridization.
Overlapping.
This process is known as hybridization. Hybridization. What is the process? The process of intermixing of Sp3d orbitals is known as hybridization. Okay. So if S and P will mix, and if they mix, and mixing of atomic orbitals belonging to the same atom and having nearly same energy is known as hybridization. I'll teach hybridization, but let us see how the bonding is done for BF3. Sp will mix, and these are the orbitals which are taking part in hybridization. After mixing, whatever the orbital they form, that is known as hybrid orbital. So hybrid orbital shape is like this. This is the shape of hybrid orbital. Okay. So you have done the shape of or AS and P. So the shape of hybrid orbital will be just like this. Means one bigger lobe, one smaller lobe. Because you are mixing all these three. So S is mixing with this. This is Sp2 hybridization, hybrid orbital. Now you are mixing three orbital. So after mixing, you will get three hybrid orbital. Because number of orbitals mixing are three, so number of hybrid orbitals will also be three. Okay. So number of hybrid orbitals are three means this is the case, and next is this one, and next is this one. And these three hybrid orbital, okay, three hybrid orbital, three hybrid orbitals will be formed. Why? Because three orbitals are taking part in hybridization. Three orbitals are mixing. So if you mix 10 ml, 10 ml, 10 ml, you will get 30 ml only, na? But suppose 10 ml of red color paint you are mixing with 10 ml of white color paint, you are mixing with 10 ml of yellow color paint, or 10 ml of red mixed with yellow plus yellow. So if you mix all three, you will get 30 ml only, na? Total will be same, na? So total three orbitals are mixing, so definitely three hybrid orbital will be formed. So this is hybrid orbital. Okay. So three hybrid orbitals are formed. Here three hybrid orbitals, say sp2, and this is sp2, and this is sp2. So three hybrid orbitals will have this shape. Why this shape? So these three hybrid orbitals must align in space. Okay. So these three orbitals must align in space so as to attain maximum stability. So as to attain maximum stability. So that is possible by having minimum repulsion. Minimum repulsion between them. Minimum repulsion between them. So now, if these three sp2 hybrid orbitals are formed, they will be lying maximum distance from each other. They will be lying maximum distance from each other. Why? Maximum distance from each other. Why like this? If they will have maximum distance, then there will be minimum repulsion. If they will have minimum repulsion, then only there will be maximum stability. So in order to attain maximum stability, they will remain in space so that there will be minimum repulsion, so maximum distance from them. So maximum distance from them, so it will be occupying a geometry, and that is called, this geometry is called trigonal planar. What geometry? Trigonal planar geometry. Okay. So these sp2 hybrid orbitals are formed, okay, that is true, but they will be formed and they will align themselves in the space so as to attain maximum stability. That is possible by having geometry of trigonal planar. Okay. So now let us draw the box diagram how they will do. S and P2 will mix, sp2 hybrid orbitals form. So we can make three hybrid orbitals because three orbitals are mixing, three orbitals are taking part in hybridization. So we will draw hybrid orbitals. Okay. So these three hybrid orbitals we can write as sp2, sp2 and sp2. So these are sp2 hybrid orbitals, sp2 hybrid orbitals. Okay. So these are sp2 hybrid orbitals. Clear? After sp2 hybrid orbitals, so these sp2 hybrid orbitals will have identical shape and equal energy. Okay, we can write all sp2 hybrid orbitals will have all sp2 hybrid orbitals will have identical shape will have identical shape and equal energy. Why like this? Because after mixing they will be divided among three, so they will have identical shape and equal energy, and their shape will be different from the orbitals taking part in hybridization, but some similar characteristics are retained, but exactly same won't be there, it will be changed. This is the shape of hybrid or any shape of any hybrid orbital, it will be more or less same, but the nature is like this. So in boron sp2 hybrid orbitals are there. Now you have fluorine atom. So
Sir,
fluorine atom can overlap. So 2p of fluorine can overlap. 2p of fluorine. 2p of which fluorine? It can be X or Y or Z. Anything. H for the choice. 2p of fluorine. I am writing 2p of fluorine. In 2p of fluorine, you have unpaired electron. So 2p of fluorine will overlap with this, with this, with this. So we get sigma bond. So this is the box diagram. Now suppose we see orbital diagram, how the bond is formed. We'll see the orbital. Suppose this is your boron atom, one sp2 hybrid orbital. This is another sp2 hybrid orbital, third sp2 hybrid orbital like this. This is your sp2, sp2, sp2 of boron. Now your fluorine atom will come. Okay, so your fluorine atom will overlap with sp2 this in this direction. So this is fluorine atom, 2p of fluorine, and here another way it can come, 2p of fluorine, and one more will come, 2p of fluorine. So they will overlap. If they overlap, all the overlappings are sp2 2p, means sp2 2p. All three are sp2 2p. So if this is the case, we will get all three will have equal what? Bond strength. They will have equal bond strength and same bond length. Same bond length. They will have equal bond strength and they will have same bond length. And they will show a geometry that is called trigonal planar geometry. And bond angle between them, the trigonal planar is there, means the bond angle between them will be 120 degree. Bond angle between them will be 120 degree. And when experiment is done, this is confirmed. If this is confirmed, then the intermixing of hybrid orbitals before overlapping is accepted. Is that clear? Have you written?
Yes, sir.
Sir,
Yes, tell me.
can you please explain from this part that hybrid orbitals will have identical shape and equal energy?
All hybrid orbitals, after mixing, they will be divided among number of orbitals mixture. So when they mix together, they show a shape like this. This is the shape of hybrid orbital. Okay, they will show a shape like this, and this type of shape will be divided among number of orbitals taking part in hybridization. Okay, if number of orbitals taking part in hybridization, then number of hybrid orbital form will also be same. So next is you can write number of hybridizing orbitals. Number of hybridizing orbital means taking part in hybridization. Taking part in hybridization. Taking part in hybridization means those orbitals which are taking part in hybridization is known as hybrid orbital. Okay, is known as hybrid orbital. Hybrid number of hybridizing orbitals must be equal to number of hybrid orbitals formed. So whatever hybrid orbitals formed, they will be distributed among number of orbitals. They will have identical shape and equal energy. So in this way, the formation of BF3 is explained, and it is assumed that all bond length equal, bond strength equal. Okay. So next, the concept comes how hybridization takes, why hybridization takes place, and when hybridization takes place. What are the conditions for the hybridization? So we must know, we must thoroughly study about hybridization. So next point of discussion is hybridization. Is it clear?
Yes, sir.
So should we start? What is hybridization? Let us start. Hybridization was given by Linus Pauling. Linus Pauling was great scientist. He got Nobel Prize in chemistry, and he died recently, 1986 or 96, I think. In 1996, he died. Okay. So Linus Pauling was a great scientist. He told about hybridization. So according to Pauling, the central atom of atomic orbitals combine to form a new set of equivalent orbitals known as hybrid orbitals. Clear? Means central atom only undergoes hybridization. Is that clear? The central atom only undergoes hybridization, and atomic orbitals of central atom, before overlapping with other orbital, they will first mix and they will combine. After combining, they form new set of equivalent orbitals known as hybrid orbitals. Okay. So unlike pure orbitals, hybrid orbitals are used in bond formation. So hybrid orbitals only form bond, not pure orbital. Hybrid orbitals only form bond. This phenomenon is known as hybridization. Okay. Or another way we can say hybridization is the process of intermixing of orbitals of slightly different energies. So this intermixing of orbitals with same energy or nearly same energy will occur. If the energy difference is very high, then it is difficult to make hybridization. So intermixing of orbitals with slightly different energies so as to redistribute their energy resulting to the formation of new orbitals with equivalent energies and shape takes place. Okay, so this is the hybridization definition. Clear? Now some silent features of hybridization so that we can know and we can understand hybridization thoroughly. The first point, it is told that the number of hybrid orbitals is equal to number of atomic orbitals that get hybridized. Means hybridizing orbitals. Means we can write whatever I wrote earlier, the number of hybridizing orbitals. Hybrid, this annotation attachment I'll send you, the number of hybridizing orbitals. The number of hybridizing orbitals must be equal to number of hybrid orbitals. Number of hybrid orbitals. So those orbitals which are taking part in hybridization known as hybridizing orbital. Those orbitals which are formed due to hybridization is known as hybrid orbitals. So hybrid orbitals number, hybridizing orbitals number must be equal. Okay. Next.
Sir, please scroll it up for a minute, please, sir.
Yes. Over.
Yes, sir.
Just you understand. Understanding is more important than remembering. If you understand thoroughly, you can remember. But thing is that once you understood, you have to revise after going home, or suppose when you do self study, that time you have to read again and recall your understanding. Okay, then you can remember forever. So next is hybridized orbitals are always equivalent in energy and shape. Their shapes will be identical and their energy will be equal. This is the characteristics of hybridization. Next, third is the hybrid orbitals are more effective in forming stable bond than pure atomic orbitals. Hybrid orbitals can form a bond that probability is more than pure orbital forming bond. Okay, and hybrid orbitals form stable bond. Next, the hybrid orbitals are directed in space in some preferred direction to have minimum repulsion between the electron pairs. So they will stay in space so as to get maximum stability. It wants what? Maximum stability. This is law of nature. Everybody wants stable. So maximum stability is the desire of these atom hybrid orbitals. So in order to have maximum stability, there will be minimum repulsion between electron pairs. Thus, a stable arrangement will be done. Therefore, the type of hybridization indicates the geometry of molecules. So they will stay in space so as to get minimum repulsion, and they make a particular geometry, and this geometry is depending upon number of hybrid orbitals. And it is told that if you have four hybrid orbitals, you have four hybrid orbitals, then they will be lying in space, they will be rearrange themselves in space so as to form a shape called tetrahedral. A shape will be there, tetrahedral. If four are there, they can make a tetrahedral shape in 3D. Actually, it is not in a plane. Suppose four hybrid orbitals are there, that four hybrid orbitals, that head is shown, tail is not shown. Actually, this is like this. This is head of hybrid orbital, this is tail. Okay, one more I am drawing. This is head of hybrid orbital, this is tail. This is head of hybrid orbital, this is tail. And one more is, this is head of hybrid orbital and one more is tail. So in this diagram, tail is not shown. This is 4 hybrid orbitals form a tetrahedron. So they form a tetrahedron by making an angle. Suppose this orbital, angle if you measure 109 degree 28 minute, and that is approximately taken 109.5 degree. This angle, this orbital also same angle. This orbital also same angle. So these are in space. This is in 3D space. This is showing a tetrahedral shape. So that 4 hybrid orbital means tetrahedral. Remember, then only it will be stable. So hybrid orbitals overlap to form sigma bond only. This you remember. Hybrid orbitals only form sigma bond. They can never form pi bond. On hybridized orbital overlap to form pi bond. So pi bond only pure p orbital, pure d orbital form. Hybrid orbital only form sigma bond. They can never form pi bond. Why? See, hybrid orbital shape is like this, head and tail. So one more head and tail. So sidewise overlapping is for restricted, because tail overlapping is difficult. So if it is pure p orbital, say like this, dumbbell, pure p, then sidewise overlapping this way possible, this way possible. Okay. So pure p orbitals form pi bond, but hybrid orbital sp2, sp3, whatever, they can form sigma bond only. They can never form pi bond. So pi bond is not possible in this, but if it is pure p orbital, pi bond is possible. Okay. Next, important conditions for hybridization. Okay, the conditions required for hybridization. The first condition is the orbitals present in the valency shell of the atom are hybridized. Okay, only the valency shell orbital gets hybridized, not the inner shell electrons will get hybridized. Only valency shell orbitals will get hybridized. Okay, we have seen in boron also, boron trifluoride case, valency shell orbital only hybridized. Okay, we can take more examples of that kind, formation of more number of molecules, but let us study about that conditions. Let us complete the theory, then we can apply for the formation and explanation of molecules. Now see, the orbitals undergoing hybridization should have almost equal energy. The orbitals, hybrid orbitals have equal energy, that only he is telling, nothing else. Okay. Promotion of electron is not essential condition prior to hybridization. See, what is telling that electrons electrons are excited to higher energy cells. Suppose ground state, they are eligible to form bond, they will form in ground state. If electrons are excited and going to higher energy cell, they also can form bond. It depends upon requirement. So promotion of electron is not essential condition prior to hybridization. Okay. So for hybridization, the electron promotion from lowest energy state to higher energy state may occur, may not occur. That also we'll discuss in the application part for methane and other molecules, ethane, ethene, ethyne, and phosphorus pentachloride. Wherever octet is violated, sulfur uh, hexafluoride, that also we'll discuss. It is not necessary that only half filled orbitals participate in hybridization. Then they've added some more conditions. First condition was the hybrid orbital will have unpaired electrons, so unpaired electron will be paired and the bond formation will be done. But it is found in some cases uh, the field orbitals also taking part in hybridization. Means kya hai? Means the the valency shell electron which is having field orbital. Field orbital means paired electrons, 2 electrons in the orbital, they also can take part in hybridization. In some cases, even field orbitals of valency shell take part in hybridization. In some other case, they do not take part in hybridization. This is also possible. So when possible, how possible, we'll discuss. Okay. Now, this point example I'll tell you. Okay. Next, see, Sp hybridization. Okay. Next is Sp hybridization. How occurs? Sp hybridization means one S will mix with one P. Which
Can
P?
you scroll up a little bit?
Which P will be mixed?
Bas-
So in Sp hybridization, you can mix Px or Py or Pz. You can mix any one of the three, no issue. Okay, depending upon requirement, it's not a choice, it's depending upon the emergency. Okay, so wherever requirement, Px may mix or Py or Pz. Okay, so if mix, they mix. After mixing, they will form hybrid orbital. That hybrid orbital we name as Sp hybrid orbital. What we name as Sp? Why Sp? Because one S, one P mixing, so Sp. So Sp hybrid orbital is shown in diagram. This is head, tail, head, tail. So Sp hybrid orbital, they can form sigma bond by overlapping head-on in the same internuclear axis. So Sp hybrid orbital is done, and they make Sp hybrid orbitals like this. Okay. Then the type of hybrid orbitals. Now see. So suppose you have electron in 2s and 2p orbitals in isolated beryllium atom. Okay. So formation of beryllium dichloride he is showing. Formation of beryllium dichloride is showing. So beryllium dichloride how will be formed? That is shown. Okay. So beryllium dichloride formation is shown. That will be formed like this. We'll discuss now. In beryllium, what is the electronic configuration? Let us see. Beryllium is having 4 electrons. So 1s2 and 2s2. So you have 2s2, both the electrons are paired. So forming bond with chlorine is difficult. So chlorine makes single bond. Now let us make the Lewis structure of beryllium, BeCl2. But beryllium valency shell contains 2 electrons. So 2 plus 2, 4 electron, incomplete octet. So by Lewis theory, we cannot explain. So in beryllium dichloride, we can say it makes 2 bond. So beryllium makes 2 bond means beryllium has to contain 2 unpaired electron. If beryllium is having 2 unpaired electron, then it can make bond with chlorine atom. Isn't it? Tell me.
Yes, sir.
So beryllium is having 2 electrons in valency shell. This is 2s2. So since beryllium is having 2 electrons in valency shell, now in valency shell it is ineligible to form bond. Suppose it has to form bond with chlorine atom, then beryllium has to occupy 2 unpaired electron. So 2 unpaired electron, how beryllium can do? Suppose 2px1, 2px0, 2py0, 2pz0. This is there. So in ground state, this will be there, but in excited state, what will happen? 2s2, one electron from S will jump to 2px1. It was 0, now it becomes 1. 2py0, 2pz0. Okay. Now what will happen? S one unpaired electron, p1 unpaired electron. Now this Sp will mix before overlapping. Before overlapping, Sp will mix. This Sp will mix. When this Sp will mix before overlapping, it will form. Wait. So it will form. Just 1 minute. Yes. So it will form hybrid orbital, but there will be 2 hybrid orbital, Sp, Sp. Okay. So you will get Sp hybrid orbital, Sp and Sp. So that is shown. So after hybridization, this electron jumps here, then you will have sp-sp. Okay, so sp-sp hybrid orbital. So once sp-sp hybrid orbital is formed, that you can show in boron like this. तो they will align in space. अगर टू हाइब्रिड ऑर्बिटल रहता है तो स्पेस में लीनियर शेप होगा. कौन सा शेप होगा? लीनियर शेप. ओके, तो sp हाइब्रिड ऑर्बिटल्स लीनियर शेप बनाएगा. यहाँ पे बोरॉन होगा, ऐसे करके एक हेड टेल, ये एक हो गया और एक ये हो गया. तो ये sp हाइब्रिड ऑर्बिटल, ये हो गया sp हाइब्रिड ऑर्बिटल, ये बोरॉन का, बेरिलियम का, सॉरी. तो बेरिलियम का क्या हो गया? sp हाइब्रिड ऑर्बिटल बन गया इसका. तो बेरिलियम का sp हाइब्रिड ऑर्बिटल बन गया. तो क्लोरीन का क्या है? 2p उसका खाली है, 2p. तो 2p खाली है मतलब 2pz हो सकता है, 2px हो सकता है, 2py हो सकता है. क्लोरीन का कैसे लिखेंगे? 1s2, 2s2, 2p6, 3s2, 3px, 3px2, 3py2, 3pz1. ऐसे लिख सकते हैं कि नहीं? बोलो. 3pz1 को 3py1, 3px1 भी लिख सकते हैं. ओके.
Sir, are you saying something?
Yes. Not audible.
Sir, it got
No,
mute
sir.
suddenly. Sir. Can you repeat that again?
हाँ. So suppose chlorine atom is there. In chlorine atom you have 1s2, 2s2, 2p6, 3s2, 3px2, 3py2, 3pz1. So if you take this, okay, if you take this, so only 2pz is backend. And hybridization occurs for central atom. Remember, it never occurs for surrounding atom. It occurs for central atom. So 2pz is the on-pair electron. So two on-pair electron should be paired. That is the rule. So 2pz of chlorine from here will overlap. Okay. तो क्लोरीन का जो है 2pz यहाँ पे ओवरलैप होगा. यहाँ पे भी z एक्सिस है तो इस तरफ भी 2pz हो सकता है, 2pz. तो 2pz ऑफ क्लोरीन यहाँ पे ओवरलैप होगा. तो यहाँ पे ओवरलैप हो गया, क्लोरीन इस तरफ आ गया, क्लोरीन इस तरफ आ गया, BeCl2 बन गया. तो बॉन्ड एंगल कितना होगा? 180 डिग्री बॉन्ड एंगल. तो इसका शेप क्या होगा? लीनियर शेप. इज दैट क्लियर?
सर ये बॉन्ड एंगल निकालने का कोई तरीका है?
बॉन्ड एंगल नहीं, कोई तरीका नहीं है. उसको हम लोग लॉजिकली सोचते हैं. और ये
सर जैसे पिछले केस में 190 की 28 मिनट निकाला अपने.
हाँ, वो 4 अगर रहेगा हाइब्रिड ऑर्बिटल तो ऐसे ही आएगा. अगर 2 रहेगा तो 180 डिग्री होगा, क्योंकि दो का मिनिमम रिपल्सन लीनियर शेप में ही हो सकता है. तो ये हो गया BeCl2 sp हाइब्रिडाइजेशन का एग्जाम्पल ऑफ sp हाइब्रिडाइजेशन. ओके, BeCl2. तो ये क्या करेगा? 2pz ऑफ क्लोरीन इसके साथ ओवरलैप होगा और एक sp और एक क्लोरीन के साथ ओवरलैप होगा, 3pz. ओके
सर,
हाँ.
तो ये हाइब्रिडाइजेशन क्या सिर्फ जो मतलब कि ऑक्टेट अगर कंप्लीट है तो उसके लिए एप्लीकेबल है या सबके लिए एप्लीकेबल है?
It is applicable for all, including octet complete, also including not complete.
सर जो ओवरलैप नहीं करेगा वो पाई बॉन्ड बनाएगा.
नहीं, पाई बॉन्ड मतलब जो हाइब्रिड ऑर्बिटल होगा वो पाई बॉन्ड नहीं बनाएगा. वैलेंसी ऑर्बिटल ओवरलैप होगा, लेकिन हाइब्रिड ऑर्बिटल सिग्मा बॉन्ड बनाएगा और ऑन हाइब्रिडाइज्ड p ऑर्बिटल, जो हाइब्रिडेशन में पार्टिसिपेट नहीं करेगा वही पाई बॉन्ड बनाएगा।
ठीक है।
पाई बॉन्ड का एग्जांपल आया नहीं अभी, आएगा आएगा, पाई बॉन्ड का एग्जांपल आएगा। अभी सिग्मा बॉन्ड कैसे बन रहा है देख लो। ओके,
तो वही सोच।
Sir, will you please scroll up a bit?
ओवर।
Yes.
See this diagram given, I think I have not told you this diagram. This diagram is intermixing of Pt orbital. Okay, so P, this is P subcell, this is D subcell. P and D are mixing. So P and D when mixing, they will mix like this. This plus will be attracted by plus, minus will be attracted by minus. So they will mix like this. And DD mixing also, D and D mixing. So D is double dumbbell, another D is double dumbbell, but double dumbbell, these two lobes plus, these two lobes minus, these two plus, these two minus. So plus plus attraction, minus minus attraction. So plus plus attraction, minus minus attraction means they will be attracted, forming pi bond, pi dt. Okay. So this is pi dt. Is it clear? Pi bond. And after.
Sir, wait for 2 minutes, sir.
सर सर
Yes.
सर यानी कि वो जो नेगेटिव नेगेटिव है वो पाई बॉन्ड फॉर्म किया?
नहीं नहीं नहीं, नेगेटिव पॉजिटिव वो एक ही लोब में रहता है, पी में पॉजिटिव नेगेटिव रहता है, डी में भी पॉजिटिव नेगेटिव रहता है। तो पाई बॉन्ड मतलब ये सब ऑन हाइब्रिडाइज ऑर्बिटल, मतलब हाइब्रिडाइजेशन में पार्टिसिपेट नहीं किया। ये ऑर्बिटल क्या है? ऑन हाइब्रिडाइज ऑर्बिटल। ऑन हाइब्रिडाइज्ड ऑर्बिटल्स मतलब ये ऑर्बिटल हाइब्रिडाइजेशन में पार्टिसिपेट नहीं किया, ये सब प्योर ऑर्बिटल। तो ये प्योर ऑर्बिटल अगर मिक्स होंगे, मतलब बॉन्ड फॉर्म करेंगे, मिक्स नहीं, ये बॉन्ड फॉर्म करेंगे, तो बॉन्ड फॉर्म में पाई बॉन्ड ही फॉर्म करेंगे, इधर पाई पीडी बॉन्ड फॉर्म करेंगे या पाई डीडी बॉन्ड फॉर्म करेंगे। ठीक है, और ये अभी नहीं चाहिए, ये मॉलिक्यूलर ऑर्बिटल थ्योरी एक है, वो जब पढ़ोगे तो ये सब डायग्राम चाहिए। इसमें एक स्टूडेंट पहले से पढ़ा था, इसीलिए मैंने इससे बता दिया, अभी ये नहीं चाहिए। अभी यहाँ तक कर लो कि जब वो बॉन्ड फॉर्म करेगा तो ऐसे साइड में साइड वाइज ओवरलैपिंग हो रहा है, ये हेड ऑन नहीं हो रहा, ये साइड वाइज ओवरलैपिंग हो रहा है, इसलिए पाई बॉन्ड बन रहा है। ये भी डी डी साइड वाइज ओवरलैपिंग हो रहा है, वो भी पाई बॉन्ड बन रहा है। ठीक है, क्लियर? तो इसका एनोटेशन वाला मिल जाएगा। ओके, इसका समझ जाओ, अगर लिखना है लिखो, ऐसा नहीं कि कुछ नहीं लिखोगे, अगर लिखना चाहते हो लिखो, जितना लिखोगे उतना जल्दी याद होगा। ओके, नीचे चले।
सर एक सेकंड।
हाँ सर।
हाँ सर।
तो नेक्स्ट sp2 हाइब्रिडाइजेशन का एक एक्सप्लेनेशन किया। sp2 हाइब्रिडाइजेशन मींस s सबसेट, s ऑर्बिटल and px py orbital or py pz or pz px, any two of this p can mix. It's not necessary that only px and py will mix. Any of the three orbitals of p subshell will mix. If they all will mix, after mixing, they will form hybrid orbital. They will form hybrid orbital of sp2. sp2 एक बन गया, यहाँ पे sp2 दो बन गया, यहाँ पे sp2 तीन बन गया. इसको अलग अलग कर दिया. लेकिन if nucleus holds all three sp2 hybrid orbital, how will be the shape? How it looks? The shape will be trigonal planar. It is a new shape. The orbital arrangement of sp2 hybrid orbital. This is sp2. This is sp2, and this is sp2. And this shape will be trigonal planar. Bond angle will be 180 degree. Why like this? Because by this it will attain maximum stability. It will have minimum repulsion and maximum distance from them, from each other. So there will be maximum stability. That's why they will form sp2 hybridization showing trigonal planar geometry. Okay.
सर तीन डिफरेंट प्लेन्स पे रहेगा ना?
नहीं, सेम प्लेन में आ जाएगा. तीन रहेगा तो
सेम प्लेन में आ
yes,
जाएगा?
same plane. It is planar. That's why
okay.
it is written trigonal planar. It can be in a same plane.
सर एक बार स्क्रॉल अप करिए थोड़ा सा. ठीक है
तो
हो गया.
नेक्स्ट देखते हैं formation of BH3 molecule. Suppose BH3 is there, so you will get boron trihydride BH3 like this. So boron is having valency shell 3 electron. So valency shell 3 electron. So if it is making 3 bond, so it will have 6 electron. So this formation is done in valency bond theory like this. So boron makes 3 bond, so 3 unpaired electron must be there. So it requires number of sigma bond is equal to number of hybrid orbitals. Okay. So it will have 3 unpaired electrons. So while forming bond, you have to remember two basic conditions. Should I tell you two basic conditions? That is condition number 1. Total number of sigma and pi bonds should be equal to sigma and pi bonds should be equal to total number of unpaired electrons at the central atom. Number 2, number of hybrid orbital should be equal to number of sigma bonds. Because on hybridized orbitals form pi bonds. Is that clear?
सर सेकंड पॉइंट मतलब समझ नहीं आया.
Number of hybrid orbitals must be equal to number of sigma bonds. Number of hybrid orbitals must be equal to number of sigma bonds. Means pi bond forms unhybridized. So if it is making hybridization, it cannot form pi bond. So that's why number of hybrid orbitals must be equal to number of sigma bond. Is that clear?
Oh, yes sir.
क्योंकि हाइब्रिड ऑर्बिटल सिग्मा बॉन्ड नहीं बनाता है, अनहाइब्रिडाइज्ड ऑर्बिटल पाई बॉन्ड बनाता है, तो इसीलिए ये कंडीशन ले लिए.
Okay sir.
ये दो कंडीशन सब में अप्लाई करोगे तो सक्सेसफुली किसी का हाइब्रिडाइजेशन बता पाओगे.
सर
हाँ,
तो जितना अनहाइब्रिडाइज्ड ऑर्बिटल्स होता है सब पाई बॉन्ड बना.
नहीं, पहले कंडीशन 1 को करना है ना. पहले देखना है कितना सिग्मा पाई बॉन्ड बन रहा है, तो उसके हिसाब से नंबर ऑफ ऑन पेयर इलेक्ट्रॉन बनाना है. तो कितना सिग्मा बॉन्ड बन रहा है उसमें हाइब्रिड ऑर्बिटल कर दो, बाकी जो बच जाएगा वही पाई बॉन्ड बनाएगा.
मतलब सर अनहाइब्रिडाइज्ड ऑर्बिटल्स जितना भी होगा सब में पाई बॉन्ड बनेगा, यही ना?
हाँ, सब में पाई बॉन्ड बनेगा, लेकिन देखना है कितना पाई बॉन्ड बन सकता है, उससे उल्टा करना है. ऐसा नहीं जितना अनहाइब्रिडाइज्ड ऑर्बिटल है उससे पाई बॉन्ड बनाएंगे, पहले देखो पाई बॉन्ड कितना हो रहा है, तो उसके हिसाब से अनहाइब्रिडाइज्ड ऑर्बिटल रखना है, उल्टा करना है. ठीक है.
ओके सर, ठीक है सर.
तो अभी देखो बोरोन सिग्मा बॉन्ड कितना बना रहा है, 1 2 3. बोरोन इज मेकिंग 3 सिग्मा बॉन्ड.
जिसमें सर एलिमेंट हो जाता है उन एलिमेंट मतलब अनहाइब्रिडाइज्ड ऑर्बिटल्स की जरूरत ही क्या हो? मतलब लोग बॉन्ड फॉर्म करते हैं.
अनहाइब्रिडाइज्ड ऑर्बिटल चाहिए क्योंकि वो पाई बॉन्ड अनहाइब्रिडाइज्ड ऑर्बिटल से ही बन सकता है, क्योंकि पाई बॉन्ड देखो ऐसे बनता है ना, साइड वाइज ओवरलैपिंग, ऐसे पाई बॉन्ड बनता है. अगर हम हाइब्रिडाइज्ड ऑर्बिटल में पाई बॉन्ड बनाएंगे नहीं बनेगा, ऐसे करके साइड वाइज ओवरलैपिंग नहीं होगा, क्योंकि ऊपर हो रहा है
तो
नीचे नहीं हो
वो
पाएगा.
तो समझे, बट मतलब तो मतलब सर बॉन्ड फिर मतलब फॉर्म करता है ये लोग का, तो फिर तो मतलब एक्सप्लेन हो जाता है ना ये लोग का, दो लोग का तो कंप्लीट हो जाता है. वो तो अनहाइब्रिडाइज्ड मतलब हाइब्रिडाइज्ड ऑर्बिटल्स तो कंप्लीट कर देता है उन लोग, उनका मतलब एक्सप्लेन कर देते हैं उन लोग का, अनपेयर्ड इलेक्ट्रॉन को पेयर कर देते हैं.
हाँ,
फिर भी तो अनहाइब्रिडाइज्ड ऑर्बिटल फिर फॉर्म करता है. और
नहीं, तुम्हारा क्वेश्चन क्या है, वो लाइन कट रहा है, ठीक से सुना ही नहीं दे रहा. व्हाट इज योर एग्जैक्ट क्वेश्चन?
सर अनहाइब्रिडाइज्ड ऑर्बिटल्स बॉन्ड फॉर्म करता है,
हाँ, वो खाली सिग्मा
मतलब ये
बॉन्ड.
जिन एलिमेंट्स में हाइब्रिडाइजेशन हो जाता है.
अनहाइब्रिडाइज्ड ऑर्बिटल खाली पाई बॉन्ड बनाता है, ओनली पाई बॉन्ड्स, ओनली पाई बॉन्ड इट फॉर्म. ओके, क्लियर?
अच्छा ठीक है सर, ठीक है सर.
अब देखो नेक्स्ट, फॉर्मेशन ऑफ बोरोन हाइड्राइड BH3 करा, फॉर्मेशन ऑफ BH3. ओके, फॉर्मेशन ऑफ BH3 में बोरोन का इलेक्ट्रॉनिक कॉन्फ़िगरेशन कितना है? बोरोन का है 2s2 2p1, लेकिन बोरोन 3 सिग्मा बॉन्ड बना रहा, तो कितना ऑन पेयर इलेक्ट्रॉन चाहिए? तो 3 सिग्मा बॉन्ड के लिए 3 ऑन पेयर इलेक्ट्रॉन चाहिए, ऐसा नो? So for 3 sigma bond, we need 3 on-pair electrons. So for 3 sigma bond, 3 on-pair electrons चाहिए. So electron of boron will be excited. So in excited state, it will jump like this. It go from here to here like this. ठीक है, क्लियर है? तो इसका इलेक्ट्रॉन जो है ऐसे जंप कर लेगा, जंप करके 3 on-pair इलेक्ट्रॉन बना लेगा, उसके बाद मिक्स होगा. S px py, मतलब sp2 मिक्सिंग होगा। तो sp2 मिक्सिंग होगा तो sp2 हाइब्रिड ऑर्बिटल बनाएगा, sp2 हाइब्रिड ऑर्बिटल्स, sp2 हाइब्रिड ऑर्बिटल्स। इज दैट क्लियर?
सॉरी बा बोलिए ना।
बोरोन का देखो एक ही ऑन पेयर इलेक्ट्रॉन है, तो बोरोन ग्राउंड स्टेट में बॉन्ड नहीं बना सकता क्योंकि उसको 3 ऑन पेयर इलेक्ट्रॉन चाहिए, क्योंकि 3 सिग्मा बॉन्ड बना रहा। तो BH3 में बोरोन 3 सिग्मा बॉन्ड बना रहा, अगर 3 सिग्मा बॉन्ड बनाएगा तो इसको 3 ऑन पेयर इलेक्ट्रॉन चाहिए। तो जब इसको 3 ऑन पेयर इलेक्ट्रॉन चाहिए तो ये इलेक्ट्रॉन एक जंप करके यहाँ आ जाएगा, ऐसे हो जाएगा 2px 2py, और ये हो गया 2s। तो बोरोन का 2s का इलेक्ट्रॉन 2px 2py में आ गया। आने के बाद ये मिक्स हो जाएगा, sp2 मिक्सिंग, sp2 हाइब्रिडाइजेशन, sp2 sp2 sp2। सो नंबर ऑफ इलेक्ट्रॉन 3, तो 3 sp2 हो गया। तो sp2 हाइब्रिडाइजेशन हो गया। sp2 हाइब्रिडाइजेशन का जो शेप होगा वो शेप हम लोग डिस्कस कर चुके हैं, ट्राइगोनल प्लानर ज्योमेट्री, ऐसे करके। और हाइड्रोजन जो है ये sp2 हाइब्रिड ऑर्बिटल, sp2 हाइब्रिड ऑर्बिटल, और ये sp2 हाइब्रिड ऑर्बिटल।
सर एक बार स्क्रॉल अप करेंगे?
हाँ,
ओके सर।
तो ये sp2 हाइब्रिड ऑर्बिटल, तो sp2 हाइब्रिड ऑर्बिटल ऑफ बोरॉन, ओके, विल ओवरलैप विथ हाइड्रोजन। हाइड्रोजन क्या क्या है, 1s ओवरलैप हो गया, 1s हाइड्रोजन, 1s ऑफ हाइड्रोजन ओवरलैप हो गया, 1s ऑफ हाइड्रोजन। तो ओवरलैप होने से ये जो ऑन पेयर इलेक्ट्रॉन था वो भी पेयर्ड हो जाएगा, यहाँ पे दिखा सकते हैं ऐसे कर। तो ये BH3 फॉर्मेशन हो गया, ठीक है। इज दैट क्लियर? अभी देखना है sp3 हाइब्रिडाइजेशन। sp3 में s px py pz all three will mix. After mixing it will give you sp3 hybrid orbital, sp3 hybrid orbital, sp3 hybrid orbitals shown in splitted. So they will align in space so as to form a shape called tetrahedral geometry, tetrahedral, okay. तो स्पेस में ऐसे रहेगा जैसे टेट्राहेड्रल ज्योमेट्री होगा, तभी ये स्टेबल होगा। दिस इज sp3 हाइब्रिडाइजेशन। इज दैट क्लियर? Now I'll show you the example of sp3 hybridization, okay, in white page. Let us take sp3 hybridization example. So now carbon, you see carbon 6 atomic number, 1s2, 2s2, 2px1, 2py1, or 2pz0. So this is carbon. Now carbon, this is there, but carbon, suppose we are taking the example of methane, formation of methane, okay. So carbon is making 4 sigma bond, because single bond it is forming, so sigma 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 sigma, so we are getting 4 sigma bond, 4 sigma bonds. So carbon is making 4 sigma bonds, okay. So you have only 2 on pair electrons, So in ground state, carbon will not be eligible to form CH4 molecule. So carbon in excited state, it will form bond. 1s2, 2s1. One electron will jump from 2s to 2pz. 2px1, 2py1, 2pz1. Now it will be eligible to form bond because you got 4 unpaired electrons. But before they overlap, they will intermix. Since you have only 4 sigma bond, so all sigma bonds should come from hybrid orbital. So Sp3 hybridization will take place. So Sp3 hybridization will occur. Tell me. Due to Sp3 hybridization, you will get 4 Sp3 hybrid orbitals. 3, 4. Okay. हेलो, हाँ मैं क्लास में हूँ. Line was disconnected. Now you go through the. Now see, is it audible now?
Yes, sir.
Now formation of CH4, Sp3 hybrid orbital of carbon, I told you, Sp3, Sp3, Sp3 and Sp3. 4 hybrid orbitals are there of carbon. Okay. Now you have hydrogen. So hydrogen 1s, 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 1s. 1s is symmetrical, so it can approach from any direction. So there will be overlapping. That is Sp3s overlapping. How many? 4. So carbon shows tetrahedral shape. We can show the tetrahedral like this. This is tetrahedral shape of carbon. Then hydrogen will overlap. Hydrogen will come here. Hydrogen will come here. Hydrogen will come here. Hydrogen will come. So unpaired electron will become paired. Okay. So unpaired electron will become paired. This is formation of CH4 molecule. Is that clear? Then sp3 hybridization is completed. Okay. Formation of C2H6 is showing. Formation of C2H6. Okay. So in C2H6, each carbon will have sp3 hybridization. Because carbon is making 4 sigma bond. Sigma, 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 sigma. So 4 sigma bond means its hybridization has to contain 4 unpaired electron, means sp3 hybridization is best. So sp3 hybridization of carbon and another sp3 hybridization of carbon, and here carbon is surrounded by 3 hydrogen. So this is hydrogen, this is hydrogen, this is hydrogen, this is carbon. Again carbon is surrounded by 3 hydrogen, so they will overlap, means these two will overlap by sp3 sp3. This is sp3 sp3 overlapping. But these all overlap is sp3s, sp3s. This is sp3s. This is sp3s. This is sp3s. This is overlapping of sp3s. Okay, is it clear? Is it clear or not?
Yes, sir.
Next, see sp3d hybridization. Okay, sp3d hybridization means what? Means S will mix with Px, Py, Pz plus D, and dz square will mix. Why dz square? Because dz square is on the axis. Dx square minus y square also on the axis, but 2 axes. This is on one axis, and remaining dxy, yz, dzx are along the axes. This is on z axis. This is on z axis. Is that clear?
No, sir. Could you explain once more?
In sp3d hybridization, dz square only participate. Why? Dz square is on the axis only. So which orbital is on the axis, that is preferred, because this mixing will give you a orbital where it is present on a axis. See, after mixing whatever is coming, that is present on a axis. So the orbital which is on axis, that will be best choice for mixing. Okay. Suppose you have to make a leaf green shading color. Okay. And you have parrot green color, you have yellow color, you have black color, you have red color. Which one you select? Tell me. In order to get leafy green color, which color you select for mixing? Parrot green, red, black, yellow. Which color you select for mixing?
Parrot green.
Parrot green and yellow, I guess.
Yes. So you will mix parrot green. The best choice is parrot green because it is similar to the leafy green style color.
Sir,
Yes.
excuse me, sir.
Yes.
Sir, can you repeat this part? I got disconnected.
So actually, if you want a shape where leaf green shading is there. So you will mix with what color? You have given option black, red, yellow, and parrot green. So in order to get dark green, which color you take? Black, red, parrot green, yellow color. Which color you should select out of this? Tell me.
Parrot green. Parrot green.
Yes,
Parrot green.
yes, that is what I am telling. Suppose you want to get a structure where one where it is along axis. Suppose you see this is on the axis. Now this shape is trigonal bipyramidal. This shape name is trigonal bipyramidal. It's not written. This is trigonal bipyramidal. TBP. Trigonal bipyramidal. Trigonal bipyramidal means TBP. So this shape TBP trigonal bipyramidal is a triangular a trigonal shape, okay, a trigonal planar shape, and above this planar shape you will get a pyramid. Okay, this is like this, and above like this, and below like this. So you will get a pyramid above. Will you get or not? If you join this point, you get a pyramid. And
Yes, sir.
below also, if you join, you get a pyramid. Okay. So that's why this shape is known as trigonal bipyramidal shape. Okay. So if you want to get trigonal bipyramidal shape, you have to take one orbital which is on the axis, isn't it? Tell me. One orbital which is on the axis.
Yes, sir.
So
Yes, sir.
on the axis only dz square exists. Others are not on one axis. Dx square minus y square is there, but that is along two axes. So you have to select dz square for mixing. If you mix dz square, then only this will come. So if these all are mixing, you will get the hybridization name is Sp3d. So the name you can write Sp3d hybridization. What hybridization? Sp3d hybridization. Is it clear? So Sp3d hybridization, if you mix how many hybrid orbital? 1, 2, 3, 4, 5. 5 hybrid orbital. So 5 hybrid orbital must align in space in order to have minimum repulsion and maximum stability. Okay. So 5 hybrid orbital will align in space of trigonal bipyramidal. What shape? Trigonal bipyramidal, like this. See, this is in one triangle, this is in one triangle, and above it one pyramid is there. You can draw pyramid if you join pyramid. Is it clear? See, this is the pyramid. Pyramid, have you seen? Have you seen pyramid?
Yes, sir. Yes, sir. Yes, sir.
So
Almost.
so this is pyramid. Similarly, one more pyramid is below it. So there will be two pyramid, that is known as trigonal bipyramidal. So this shape will come if you mix all these 5. Is it clear?
Yes, sir. Yes, sir.
Trigonal bipyramidal, TBP shape. So Sp3d shape is trigonal bipyramidal shape. This is the shape. Example I tell you. Example I tell you. First you see the different possibilities. Okay. Next, let us see the hybridization of Sp3d hybridization. Means S, Px, Py, Pz and dx square minus y square and dz square. If these two are mixing, you will get Sp3d hybridization. You will get Sp3d hybridization. And if you get Sp3d hybridization, you will have 6 hybrid orbitals. 6 hybrid orbitals will align in space like this: 1, 2, 3, 4, 5, 6. These are 6 hybrid orbitals. Is it clear? And it looks like this: 1, 2, 3, 4, 5, 6. So this is looking like a square, and if you join this point, it looks like a pyramid. Is it clear?
Yes, sir. Yes, sir.
This geometry is called square bipyramidal. What? Square bipyramidal. Means a pyramid is there from a square base. Can you have pyramid from square base? Triangle base? So this is a pyramid whose base is a square. Can you have? Have you seen pyramid?
Yes, sir. Yes, sir.
Have you gone to Misr? Pyramid is found
Yes, sir.
where pyramid is found? Egypt.
Yes, sir. Yes, sir.
Have you gone Egypt?
No, sir. No.
No, sir. No, sir.
So Egypt, Cairo.
Sir, seen models of the pyramids.
Yes. Can you
I've seen
imagine?
models.
You can imagine, na?
Yes, sir.
So pyramidal shape. So suppose S and P, X, Py, Pz and dx square minus y square dz square all will be mixed. If all will be mixed, it will show square bipyramidal. Means square is there, a pyramid above it and below it. So we say square bipyramidal. This is also known as octahedral. This is also known as octahedral. Are octahedral, why? Why it is octahedral? Because it has 8 faces. How many faces? 8 faces. How 8 faces? See, this side one face. This is one face. I am drawing square pyramidal. This is one face. Okay. Now let us take one more face this side. And now take more faces. Okay. So back side one face. Is it possible or not? Back side. That back side one face. So 1, 2, 3. And you will have front side one face. So front side one face you will have this one. Is it clear? समझ में आ रहा है कि नहीं?
Sir.
So suppose square pyramidal if you make, you will have 1, 2, 3 and backside one face. So 4 faces in one square pyramidal and below it 4 faces. So 4 plus 4 you will have 8 faces. तो यहाँ पे देखो 1, 2, 3 पीछे 1, 4 हो गया. तो ऐसे करके इसको भी नीचे भी कर दोगे तो इधर भी 1, 2, 3, 4 आगे पीछे 4 लेफ्ट राइट 4 4 4 8 फेसेस आएगा. तो 8 फेसेस जो आएगा इसको बोलेंगे हम ऑक्टाहेड्रल और स्क्वायर बाइपिरामिडल. दोनों नाम सही है इसका. तो Sp3d मींस ऑक्टाहेड्रल स्क्वायर बाइपिरामिडल आएगा. तो इसको ब्रैकेट में क्यों डाला, इसको ब्रैकेट में रखने का क्या मतलब है? ब्रैकेट में इसलिए रखा क्योंकि sp2d जो है, sp2d एक अलग है और p और d अलग टाइप का मिक्सिंग होता है। ठीक है, अभी ये इसका बेंड्स रूल एक है, वहां पे समझ में आएगा। अभी हाइब्रिडाइजेशन याद रख लो, ये दोनों ही मिक्स होता है। क्यों यही दोनों मिक्स होता है? dxy dyz dzx मिक्स होने से होगा? नहीं होगा। मिक्स होने से ये वाला शेप नहीं आएगा। ऐसा क्यों? dx square minus y square is on axis. This is along axis, on the axis. It lies on the axis. And dz square is also on the axis. If you take these two, then in square bipyramidal or octahedral, you will get in 3 axes. देखो एक एक्सिस यहाँ आ रहा और एक एक्सिस यहाँ जा रहा और एक एक्सिस यहाँ आ रहा। तो ये जो शेप आ रहा ये 3 एक्सिस में आ रहा। ये अगर 3 एक्सिस में आएगा, इस शेप आने के लिए हमें वही ऑर्बिटल लेना है जो ऑन एक्सिस है। अगर हम dxy dyz dzx लेंगे, ये विद इन एक्सिस आ रहा। these are within axes. अगर विद इन एक्सिस हम लेंगे तो ये आएगा क्या? ये नहीं आएगा। ऑन एक्सिस जो लाई करता है उसको लेने से ये आएगा। ओके, इज दैट क्लियर?
सर
यस, टेल मी।
फिर ये सब मतलब हाउ विल वी ड्रॉ इन आवर नोटबुक?
Notebook, you see and draw. You are very good at drawing and you can see and draw. I am drawing. Suppose you want, I can draw also on this white.
So like how do we show the 3D thing?
3D like this you show. This is the one, or you show like this. This is 1, this is 2, this is 3, this is 4. Done. And one is above it and one is below it. Like this you show. Broken line you show. So this you join. This is square in order to get the shape. And above it one pyramid, below it one pyramid. This is sp3d2. Okay. Completed sp3d2 hybridization. Examples will take. Don't worry. We'll take examples. Next is sp3d3 hybridization. Means you will take S, Px, Py, Pz. You will take X, Px, Py, Pz. All three you will take. Okay. So if you take all these three, then you need to take dx square minus y square. You need to take dx square minus y square, dz square, and dxy. Remember, if you take these three, then only sp3d3 hybridization. Previously, you took dx square minus y square, dz square. Now, one more d you have to take. That only you have to take dxy. Why? Because dxy and dx square minus y square are similar. These are along x and y axis. These are along x and y axis. And dxy is within x and y axis. dxy is within x and y axis. And dx square minus y square is on x and y axis. It is on x and y axis. This is within x and y axis. So they will be similar because both are in xy plane. This is xy plane. This is also xy plane. So both are similar. So mixing is easy. Suppose two students with similar nature, so their mixing is easy. They can be good friend. Suppose one is very cool minded, another is very angry mood. Okay, so mixing and making friendship is difficult. So similar orbitals mixing is easy. So that's why if they are mixing, then they will give sp3d3 hybridization. Sp3d3 hybridization shape is pentagonal bipyramidal. Pentagonal bipyramidal. So pentagonal bipyramidal means a pentagon in a plane and a pyramid above it, below it. Suppose pentagon we take. Pentagon you have known, you know pentagon. 1, 2, 3, 4, 1, 2, 3, 4, 5. So you join, you got a pentagon. So this pentagon you draw in one plane and you take one axis above it and below it. So if you take axis like this, one axis intersecting the center of mass of a pentagon, okay, another you take like this and broken line because this is below that. So if you take like this is pentagonal bipyramidal. So pentagon, if you keep atom here, say one atom is here, fluorine atom, let us take. This is another fluorine atom. This is third fluorine atom. This is fourth fluorine atom. And this is fifth fluorine atom. Okay. And your iodine is there at the middle. And sixth fluorine is axial. And seventh fluorine is axial. So in IF7, you will have pentagon, a pyramid is one half and below half is another pyramid. Upper half one pyramid. So pentagonal bipyramidal is the name of the shape. The shape is looking like a pentagonal bipyramidal. We can draw geometry like this. Is that clear?
Yes, sir.
So in Sp3d3, we will get pentagonal bipyramidal. Now there are many shortcut methods to find hybridization. We have three shortcut methods to find hybridization. Okay. So we have conceptual method and we have shortcut method also. So do you want to know both the methods or only shortcut methods?
So,
Yes, both the methods. Now let us first start. Now let us take the formation of PCl5. Okay. So in PCl5, what you find, phosphorus is making sigma bond with chlorine because chlorine can make only sigma bond with phosphorus. Chlorine has 2 PZ, 3 PZ on pair electron. So chlorine makes single bond, so phosphorus has to make 5 bond with 5 chlorine atom. So this should be the Lewis structure. But phosphorus octet is violated. It is more than octet. Phosphorus is having valency shell electron 5 and it is making 5 sigma bond. So it is 5 plus 5, 10. So how it is formed? So that is explained in valency bond theory. So phosphorus having 15 atomic number. So 1s2, 2s2, 2p6, 3s2, 3p3. Okay. So valency shell 3s2 and 3p3. So 3s2, 3p3 is there. So in ground state, this cannot form. Ground state, it will be ineligible to form bond. It cannot form bond because it is making 5 sigma bond. How many sigma bond? 5 sigma bonds. So if it is making 5 sigma bonds, it needs 5 unpaired electron, but there are only 3. So in excited state, some of the electron will jump. Some of the electron will jump from 3s, 3p, 3d. It will jump to 3d. Let us write 3p here. This is 3s, 3p here, 3d. So some of the electron will jump to 3d. So if it will jump to 3d, then so we need 5 unpaired electron. Already we have 3. So if electron will jump, one electron will jump from 3s to any of the 3d, then we'll get 5 unpaired electron. We are getting 5 unpaired electron. So now all the 5 unpaired electrons will mix together. They will mix together. So if these 5 unpaired electrons will mix together, they will form what hybridization? Sp3d, because Sp3d is coming. It is going to D. Sp3d, 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 Sp3d. So 5 unpaired electrons are there. Sp3d, Sp3d, 5 unpaired electrons in phosphorus. This is phosphorus. Now phosphorus is making bond with chlorine. So chlorine, what is there? Chlorine 3pz is there vacant. So 3pz you can write 3px1, 3py1 or 3pz1. So chlorine, let us write the electronic configuration of chlorine. Chlorine 17, 1s2, 2s2, 2p6, 3s2, 3px2, 3py2, 3pz1. So 3pz1 you can also write 3px1 by making 3pz2 or 3py1 making 3px2 and 3pz2. Whatever you can make. So chlorine you can write or 3px1, 3py2, 3pz2 remaining same, or 3px2, 3p, 3py1, 3pz2. So these 3 ways you can write. So if you write 3 ways, then your 3p of chlorine will overlap with all. So like this, 3p of chlorine, 3p of chlorine, and 3p of chlorine, and 3p of chlorine, and 3p of chlorine overlap. So they will make what bond? All sigma bond. Sigma, 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 sigma. So 5 sigma bonds are formed. Suppose you want the orbital diagram. Suppose you want to draw orbital diagram of this. This is box diagram. So orbital diagram you can draw from this like this. So it is trigonal phosphorus,
Pyramidal.
trigonal planar phosphorus is making. It is there in phosphorus. Trigonal bipyramidal it is making phosphorus. So bipyramidal you take one axis, another axis. So see, these are trigonal bipyramidal. This is in one plane, trigonal plane. This is in axis. So this bond is known as axial bond, and this bond is known as, these 3 bonds are known as equatorial bond. Axial bond and equatorial bond. So this phosphorus is having 3 equatorial bond and 2 axial bond, and this is the phosphorus, and your chlorine atom. So your chlorine atom will overlap here like this, chlorine, 3p of chlorine. Another 3p of chlorine will overlap here, this side. Another 3p of chlorine will overlap this side. Okay. Then two 3p of chlorine will overlap on axis. So like this, 5 3p of chlorine will overlap chlorine, 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 chlorine. 5 3p of chlorine will overlap. So this is Sp3d, 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 and Sp3d, and these are chlorine overlap. Is that clear? Formation of PCl5 हो गया कि नहीं?
हाँ सर.
Yes, sir.
हाँ सर.
Have you written? Take screenshot.
Yes, sir.
So over completed.
Yes, sir.
Now I am giving homework. So you have to make formation of C2H4. C2H2. Okay. And SO4 2 minus. PO4 3 minus. SO2. SO3. Okay, SO2. SO2 you cannot do now. You try this. Okay. Some more I write.
Okay, sir.
CO2. Okay. 1, 2, 3, 4, 5, 6. So 6 homework I am giving. So you do it and you have to draw box diagram for each. And you have to draw orbital diagram. And you have to send me in my WhatsApp number. Okay. So you have to do these 6. And send me in WhatsApp group, right? Will you do this homework?
Sir, in the group or personally,
Personally,
sir?
you send me. I will check. Okay.
Sir, by today.
By tomorrow.
Okay, sir. By tomorrow.
So by tomorrow you do these 6 and send me.
Yes, sir.
These 2 you might have problem. These 2 are a little difficult, but if you try also you can do. These others you can also try. Try to do the formation of these all. And if you don't get, you see some books and you can understand, and after that you can do it again without seeing and send me. Okay, so this is homework for you all, right? Then
Thank you, sir.
so okay.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Okay, welcome. I'm closing. So I'm doing video for today. If it is successfully done, I'll send you. Okay.